Okay, so now we're going to do an example where we learn more about Q. Q is needed to solve the shear stress of a beam and bending. And here's the first example, which asks, compute the first moment area, which is Q, about the x-axis of this shape that has a base of 100 and a height of 200. Now when you solve any of these problems in this chapter, the first thing to do is to get Q. And the first thing to know about Q is a special note is to only consider half of the shape. This is a special note that's going to help you to solve this. Only consider half of the shape. Well, what does that mean? That means that if I specify I want to know Q about this x-axis here, then I only really care about the shape below it or the shape above it. This guy's symmetrical, so for this problem, I only really care about this half. It could be the top half, it's symmetrical, we'll get the same answer. But I only really care about that bottom half. That's the most important thing. Now let's remind ourselves what the formula for Q is. Q is equal to AP times Y bar. Okay, so we need to get those things. So AP in the previous formula, or in the previous slide, said that it is just the area of the shape above or below the axis. Well, all that means, if I'm just considering one of the bottom areas, then AP is just going to equal 200 millimeters. I'm getting 200 millimeters from the height. That's the height of the overall thing. I just want the height up to x. So 200 millimeters divided by 2 gives me the height of just from here, you can see my cursor, up to x, half of the area. That's just the length. That needs to be multiplied by 100 millimeters, which is the thickness or the base. And that's equal, I just do this math, and that's equal to 10,000 millimeters squared. Again, how did I get that? I did 200 millimeters divided by 2 is this. Wow, that's a really nice straight line. Let's use the line tool. That's 100 millimeters. And that's 100 millimeters. Which gives me the 10,000 millimeters squared. Well, I can't do a straight line. Okay. Then, what is Y bar? Well, Y bar, it's not the distance from the bottom to the X. It's Y bar for just this shape. All this is always for just half of the shape. So, Y bar is going to be from here to about there. Because the centroid for just this shape is about right there. Okay, remember we're just dealing with just half of it, not the whole thing for this entire problem. So then, let's change this to black. Then Y bar is equal to 200 millimeters, which is the entire length, 200 millimeters. If I divide it by 2, that just gets me to the X. So I'm just going to divide it by 4. If I do that, that equals 50 millimeters. This little distance of this line right here is 50 millimeters. That's the same from the bottom or from X to that location, still 50 millimeters. Now that I've figured out both of those, now Q is just equal to 10,000 millimeters squared times 50 50 millimeters, and I just plug that into my calculator, and I will get 500,000. What should my units be? Well, it's millimeters squared times the millimeters. So Q is in length to the third power. If we're working with inches, it'll be inches to the third. If we're working with feet, it'll be feet to the third. And that's how we do Q. The most important thing, again, I'll reiterate, is only consider half of the shape. If it's a rectangle, it's easy, then just pick the bottom or the top, you'll get the exact same thing. So therefore, AP was just this area. Y bar was the distance to the centroid of just that shape. And that's it. And I just multiply them together, and that's how you do Q. I'm going to cut this video and get back to the lecture.